Enterprises and service providers are faced with the challenge to deliver not only performance, but performance that is ultra-scalable with security built in. The FortiGate 7121F series, powered by Fortinet's industry-leading SPU ASICs, rises to this challenge with unprecedented threat protection and SSL inspection performance. The groundbreaking performance of the FortiGate 7121F outpaced the capabilities of our traditional test solutions, so to fully characterize the performance of the FortiGate 7121F, we reached out to Keysight for early access to their all-new, unmatched next-generation application and security test platform, the APS Series. This allowed us to recreate hyperscale environments in a modular grow-as-you-need approach. The APS M1010 controller manages the APS 1100 traffic generation modules, distributing the load with a modular test system that scales linearly to include up to 10 traffic-generating devices. For this performance test, we used the maximum, 10 APS 1100 appliances to push our system to the performance requirement. The test system is driven by Keysight's BreakingPoint test software, which we have used for many years, greatly simplifying our validation efforts. To truly characterize the performance of the FortiGate 7121F, we focused on two scenarios most often asked for from our enterprise customers: application control with web filtering and threat protection with security attacks. The first is one that's typically requested by educational institutions to protect children from harmful or illegal content. The traffic generated for this test is HTTP traffic with a 64 kilobyte payload, to ensure that our test results can be directly compared with datasheet test results of competing next-generation firewall products. The traffic also includes a mix of random URLs. Why is this test scenario important? It's a true gauge of the number of connections per second the device can handle. Think of it as the same kind of traffic as students browsing in school. The other key component is whether the URL requests are being logged to provide full visibility. Here's a quick look at the HTTP traffic pattern on BreakingPoint, where we use HTTP traffic with a 64 kilobyte payload and a mix of random HTTP URLs. This is the firewall policy with application control and web filtering, as well as logging for every session for enhanced visibility. The test has started running, so let's take a look at the CPU and BreakingPoint traffic at the same time. Note that we are fast-forwarding the test for this video demonstration. The complete test included a 10-minute longevity test as a requirement, which completed with no drops or transaction or connection failures. Let's take a quick look at the frame rate. Each of these ports is hitting approximately 94 gigabits per second, with 12 interfaces in total. The FortiGate 7121F can reach 1.13 terabits per second of HTTP 64 kilobyte traffic and approximately 2 million connections per second with web filtering and application control enabled. We also want to highlight a key differentiator of the FortiGate 7121F, the separation of management and data plane, which is clear from the CPU monitoring widgets on the left. The data plane CPU processes all the security functions. In this case, web filtering and application control are at 94% CPU, while the management CPU is only at 2%, not impacted by the high traffic load. The other key part of our testing is that for the 2 million connections per second that we mentioned earlier, all of the traffic was logged to provide visibility and actionable intelligence, in addition to the web filtering and application control abilities. The log rate can also be seen below, at about 23 gigabits per second of log traffic. The test is concluded based on our test criteria, successfully running at a peak rate for 10 minutes with no transaction or connection failures. This test demonstration highlights our performance with application control and web filtering, as well as full logging enabled to reach a maximum of 1.14 terabits per second of throughput. With that, let's move on to the next section of our testing: threat protection with security attacks. Our second test simulates scenarios typical to enterprise customers and managed service providers. Security attacks are on the rise. For instance, ransomware attacks which cause business disruptions resulting in brand damage. As a result, many organizations enable multiple security functions, such as application control, intrusion prevention, and antivirus, as a line of defense to detect and block attacks. An important requirement is logging, for organizations to gain better visibility into their traffic patterns and the threats detected and blocked. For these organizations, it's critical to characterize how the system In this case, our FortiGate 7121F performs with multiple security services enabled, and in addition, whether the system can accurately block security attacks and send out the traffic logs without impacting performance, even under heavy load. These are some of the key items we will show in the upcoming scenario. This is the security policy with application control enabled, the intrusion prevention profile set to high security to block attacks, and antivirus. Deep inspection for HTTPS traffic is also included in the policy configuration, as we do this for other tests. But for the purposes of this test, only HTTP traffic with a 64 kilobyte payload will be sent to measure the bandwidth that can be handled. Now we start up the test. Similar to the first test, we can see the traffic is a total of 639 gigabits per second, evenly distributed across 12 interfaces, each running approximately 53.3 gigabits per second. As in our previous demonstration, the FortiGate 7121F has clear separation of management and data plane. The data plane CPU is at 90% load, while the management CPU is not impacted, and the logging traffic rate is at 12.9 gigabits per second. Now let's take a look at the attacks being sent. So far, all of the 237 attacks have been successfully blocked. We'll be sending a total of 448 attacks for this test. We're almost to the end of the test, and all attacks have been successfully blocked. That brings us to the conclusion of this last test. We achieved 639 gigabits per second of threat protection throughput with HTTP 64 kilobyte traffic, and successfully blocked all attacks sent during the test with logging enabled for all traffic.